today we'll be starting the inclined plane. Projectile motion. Now in this case, the method to throw the object will be same, but it will hit the inclined plane instead of the horizontal plane. So if we have something like this, a plane like this, there are two possibilities. You can throw either up the plane or you can throw down the plane. So the first thing that we consider is called the angle of inclination. So let's call this angle of inclination as alpha. The second thing is called the angle of projection. So the way we were throwing, the same thing will happen. And the way we were taking the angle, the same thing will maintain. So I will take theta from horizontal. Nothing will change. Now, in fact, nothing is changing. I mean, it's not different from the oblique one. So what is happening here is that this projectile will move in a path and will be intercepted actually. If there is no plane, it would have traveled till the bottom the way it did earlier. So technically, this is just oblique projectile which is intercepted by the plane. So in a way, you have just disturbed the path of the projectile, like you have brought something in between, and so the journey will end here only. So our projectile motion will terminate the moment it is about to hit the plane. So the moment it is about to hit the plane, our journey will terminate. And again, the time of flight in this case, when we try to define, it will be defined from going from O to A only. So now the time of flight is the t taken to go to O to A, not from going from O to B. Okay. So if you throw with velocity v naught, then how to deal with the problem? So it's pretty easy to deal with the problem, not an issue. So we can play some tricks and we can solve this question easily. So what are the tricks that we play with? So let's consider the axis as usual, like the way we used to assume earlier. Let's make no change to this. So let's consider the axis as usual, like without making any change. So I'm calling this as x-axis and the y-axis as usual. Nothing changed. No changes. Okay. But we in this case we are also going to consider two, like one extra pair of coordinate axis in which the plane will denote one direction. So let's call this as x dash. It is not the same. And the other one we can call it y dash, which is again perpendicular to the inclined plane. This is y dash. So we have the Cartesian system, two set of, I mean, you can say two set of Cartesian system, and we'll try to see how this assumption makes the calculation really easy. So imagine there is a guy sitting over this plane. For this guy, the particle has started from y dash equals to 0. You can see the y dash. And when the object is landing at A, what is the y dash again? Can you see the y dash?
Yes, sir.
Can you see the y dash in the end? No. Yes. What is y dash at the end of the
Sir,
journey? Yes.
sir, can you repeat,
Sir,
sir? Your phone
zero.
was not able to
No,
hear.
sir, it is same as the downward direction.
Y dash is negative y dash.
No, no. What is the y dash? Y dash means what? Like how above from the x dash axis, right? So when you land on the x dash axis, it means you're on the y dash equals to 0. But if you look from the the xy plane, if you look at the x axis, is it landing on the x axis? The answer is no. It is above the x axis. We can see clearly. So it will have a coordinate x comma y, but it will also have the coordinate x dash comma 0. Now that's very interesting. And the origin is common, so you can say that it will have coordinate 0 comma 0 for the first coordinate system and 0 comma 0 for the other coordinate system. So what we can see, what we can understand is that the purpose of making such assumptions, or the purpose of taking such a coordinate system, is to make the calculation easier, nothing else. So what I can say that for the given journey, there is no displacement along the y dash. See, there is a displacement, but there is no displacement along which direction? Y dash. And as I said, we can always solve any projectile motion along any two mutually perpendicular axes, need not to be horizontal and vertical. It can be any two pair. And so is our case. So we are taking the case that calling the motion along the x, along the plane itself as x dash and y dash respectively. Things are pretty easy for us. Again, before we solve this question, let's try to find the components. So we will have the x and y component first. So what is ux? It's the same thing as we used to
V
do
naught
earlier.
cos theta.
Yeah, so it's v naught plus theta. And what is y component? V naught sin theta. So the ux, the v naught cos theta and the v naught sin theta are the components. Now what is ax?
0. 0.
What is ay?
Minus g. Minus g.
No. Now let's do the same thing for x dash and y dash respectively. What is ux dash?
So V naught cos theta minus alpha.
Very
Yes.
good. And what is uy dash?
V naught sin theta minus alpha.
Very good. What is ax dash?
0. 0.
No. Ax is, you are saying that there is no component of acceleration along the x dash direction. This is what you are saying. But if you look carefully, the g always acts downward, right? So now we can show it here. That's a better version. So this is how the g acts, right? And what you are saying is that there is no component along the x dash. Is it true? Like we can't find any component. This angle is how much? So can we resolve the g along the x dash direction? Definitely we can resolve. And in fact, I can see also. So what I can see that if I draw a perpendicular from here to the x dash, I can see the component. So what is the component of g along this direction? And you can find it's opposite to x dash, and the value is g cos 90 minus alpha. And there is another component which we know, which is perpendicular to the x dash axis. So now here is the game changer. The acceleration cannot be zero for these two directions. And in fact, the acceleration turns out to be having component in both the direction. The one which is perpendicular is g cos alpha, and the one which is parallel to the x-axis is called g sin alpha. And both are pointing opposite to the axis, the positive axis. So one is against the x dash, other is against the y dash. So both are negative. If I ask you what is ax dash, so answer will change from g minus g sin alpha. What is ay dash? The answer is minus g cos alpha. Now this is very important part of this projectile motion. That acceleration we cannot just jump to and say zero. We need to see the vector and we need to resolve the vector. Now, if you take the x and y axis, then definitely the g cannot have component along the x axis because they are mutually perpendicular. So if a vector is not mutually perpendicular to a given direction, then it means it will have component. So the rule is simple. A vector will have component in all direction except the direction perpendicular to itself. Understood? And this we have been talking about since the vector chapter. So the idea is simple that any vector will have component in all possible direction except the direction of perpendicular to itself. That is the key idea that you need to remember. So now having the component ax dash and ay dash as g sin alpha and g cos alpha, we can definitely write the kinematical equation in all directions, like every coordinate system that we have taken. So let's say I suddenly become interested in finding the time of flight. That's my interest. So how I can think about it, like what I can do to get this answer? In how many ways I can find time of flight? Like what are the possible ways to think about this problem? Or what I know, like what kind of event which I can say that has happened in one time of flight. So if you look at the situation of the diagram here, can you figure it out like what happened exactly during one time of flight? So do you know the displacement along the x? Do you know? Yes or no?
Uh, Sorry.
You don't know? Okay. Do you know the displacement along y-axis?
No.
No. Do you know the displacement along the x dash axis?
No.
No. Do you know the displacement along the y dash axis?
No.
No.
No, you know
Zero.
that is what. Yes, so you started with the zero and now you land at zero only. So in case of y dash, it is magical. Now we know one thing at least, that there is no displacement along the y dash direction. Now that is the key concept we need to pick up. So once you are sure that you know something about the motion, you can write the kinematical equation in that direction in which you know something to get the desired answer. So now what we need to do to get the time of flight? What option do I have?
So S is equal to ut plus half at square. We can apply that for y dash.
Exactly. So because we know the displacement formula, so we must apply for time of flight. So we don't solve question randomly. We always go with the logic. Like I have to solve a question, particular question, and in every other case, we try to always find the displacement. So we try to find the displacement on the x-axis. Okay, no idea. Y, no idea. X dash, no idea. But y dash suddenly it gives you the answer. And therefore, I must write that y dash minus y naught dash equals to u y dash t plus half a y dash t square. And the moment you go with this, expression, you will be able to achieve the answer. Okay. So we know that at t equals to 0, the y dash is 0. At t equals to time of flight, y dash is again 0, which means y naught is 0 and y dash is 0. So you can substitute the answer. So what do we get here? 0 minus 0 equals to what is uy dash? So uy dash turns out to be v naught sine theta minus alpha into t. And what about the half ay dash? It's minus g cos alpha into t square. And if you solve, you get the answer which you have been getting. The difference is okay. So here again we use the concept of displacement. So this is actually like 2uy dash upon mod of ay dash. So this formula you can remember this way. So it is similar to the oblique formula. The only difference is I have changed the axis. And what you need to remember that the moment you change the axis from horizontal to anything else, the g will bring its component in both directions. Now that realization is very, very important. That the g is having no component along x or horizontal, but it will have component along any other direction. Okay. So now you got the time of flight. Okay. So I think now you are like having the powerful information. So someone knowing the time, can you find the x coordinate of A, y coordinate of A? Can you find this height? Let's call it C. So if I ask you, can you find AC? Can you find OC? Because you know time of flight, so and you know the horizontal component and all. So can you find the OC?
Yes, sir.
Can you find OA? Can you find the AC? What are the things you can find? So actually, you can find everything because once you know the time, you can find all displacement, right? So what is AC? By the way, tell me AC, OC, OA. Three things. So now because you know everything, so find OA, OC, AC. And this thing will matter. I mean, these things are very, very interesting facts. Okay, so let's call it this as H. So I'm looking for H also. What is H? Like at what height will hit the plane, the inclined plane? Can you do this? Hello, hello, hello. Are you solving?
Yes. Yeah, sir.
Okay, go ahead.
Sir, OA is UX dash square divided by mod of
Hmm.
AX dash.
AX dash. What is this AX dash? I want to answer in terms of the basic parameters like V naught, theta, alpha,
Sir, I
all those.
got yeah, I got in same parameters, sir. So should I tell them?
Okay, you try once again. Try properly. Okay. Use the kinematical
Sir,
equation
no,
and then get the answer.
I'm different. Sir, I have
Okay, what
different.
is OC?
Sir, I got you said to find OA no first.
Yeah, what is OA?
OA I got V naught square sine 2
Hmm.
theta minus alpha divided by
Hmm.
g cos alpha minus
Hmm.
tan alpha sec alpha by 2g.
Okay. Okay. So you simplify this. Then I'm checking once again.
Sir, I got H as a little big answer.
Sir, OC is equal to V naught cos theta t.
Yeah, how much?
V naught cos
OC.
theta t.
Correct. Yeah, that's the right answer. Now, once you go to the OC, you can find OA by the trigo.
Yes.
Sir, OA I found by sine alpha is equal to H by OA. Sir,
But H is not given, right? So you cannot use that formula.
sir, yeah, sir, to find H only we can use that formula, no? Sine alpha equals to H by OA. So OA I found out already. So I'm putting every values of OA in that sine multiplying by sine alpha. And sir,
Yeah,
I can get
but
it.
yes, you can do that. So you can find the OC part, the way you said V not cos it into T. And then once you know the base of the triangle, the lower triangle, you can see the right angle triangle, right? You can see that triangle. So in that triangle, just apply the trigo to get the OA. That is easier way to get OA, in fact, isn't it?
Ah, yes. Sir, but t by 2 will come with it.
Pardon?
Like V naught cos theta minus alpha t by 2.
No, no. Why? For OC, what is the answer? What is OC?
V naught cos theta t.
That's it. So now you have to take the Take the
Okay.
trigo part. Like you can write, let's say OA cos alpha is V naught cos theta into T. Can you see that? OA cos alpha is how much? Same as OC, isn't it?
Yes, sir.
Sir, OC, I'm getting like something range minus something n alpha by 2g, which is V naught squared sine 2 theta minus alpha by g minus tan alpha by 2g.
Just one. Let me see.
Sir, I got the answer.
Just give me 2 minutes. 2 minutes. I'm fine. So the easiest trick was to find OC, and once you get the OC, it is no longer the question of projectile; it's a question of mathematics or trigonometry. So finding OA is actually much easier if you know the OC actually. And what I'm emphasizing is don't use the like physics, just use the mathematics. So can we write OA cos alpha equals to OC? And what is OA then? OC by cos alpha, right? Is this clear?
Yeah, sir.
And OC we know already the answer. It's V naught cos theta into T. And in fact, we know the answer for T also, right? So the OA is nothing but the range of the projectile. So actually, we were trying to find the range actually. So in this case, a range of projectile is actually OA, and you got the answer is OC by cos alpha. So what is the range formula if I want to substitute everything? And then you can substitute the value of V naught cos theta by cos alpha. And the time of flight was 2 V naught sine theta minus alpha upon G cos alpha. So range is having very nice formula. It's V naught square by G cos square alpha. And then we have something, a big expression, which is a function of theta. So the plane having fixed angle of inclination. So alpha is a constant. Let's say your ability to throw something is constant. Let's say V naught is constant. Now to change the range or to maximize or change the range value, the only thing that will change is the theta. So as theta will vary, what do we expect? As theta will vary, the range will also vary, isn't it? So theta will change with the range. And in fact, we can plot this graph on GeoGebra and we can vary the theta to see what are the answer. So theta will vary from where to where. Like of course we'll throw more than alpha. So we should vary theta from alpha to 90. Alpha, let's choose some alpha. Let's call alpha is 30 degree or pi by 6. And I have to change this to pi by 2. So what is pi by 6 and pi by 2? Numerically, how much is that? I want to make it numerical value. It's pi by 6 is
30
3.14 by,
degree.
no, no. Pi is 3.14, right? By 6 is 0.5232. Pi by 2 is 1.56. No, you don't know why I'm doing this. This is I'm doing for the purpose of graph. Okay. So let me show you the graph. There are two graphs, y equals to. So basically, if you look at the graph, we have a graph of a parabola and we have a graph of a straight line. These are two different graphs actually. So the previous question is like intersection of two graphs. Mathematically, it's a intersection of two graphs, and we should be able to solve using the graph method. So if you remember the equation of trajectory in the range formula, I mean, I hope you remember this: x tan theta 1 minus x by r. I hope do you remember this?
Yes, sir.
Yes,
This
sir.
is the equation. This is the equation of this graph. This graph. Okay. And this is a pretty simple graph. This is like y equals to mx, which is like x tan alpha. So when both will be equal, so this is the point of intersection. So if you equate these two, you will get something very interesting answer. And this range is this range, the bigger range, because that is the formula. So to find the point of intersection, we can just equate these two equations. So instead of solving by the the concept of projectile, you can solve by the concept of graph actually. So there are various perspectives in which we can solve. So if you solve using using graph. So if I just redraw the circuit, I mean not circuit, redraw the diagram. I'm teaching so many chapters, so sometimes I can blot out in rotation, something. All right. So actually, this is not there. This is just I'm showing. So you are throwing with velocity v naught, angle is theta, and so on. So this is also line, question of line. So this is y equals to mx, and m is actually here 10 alpha. And this graph is y equals to x tan theta 1 minus x by this range. Now I will talk about the range. Okay, and if you solve, what you can get x tan alpha equals to x tan theta 1 minus x by r. That's nice. Oh, that's nice. X will cancel. So this, we know one intersection is 0, so I'm just canceling out. I want to the other answer. So this is quite easy to understand. This is tan alpha by tan theta equals to 1 minus x by r. So our job is done. X by r is how much? 1 minus tan alpha by tan theta. I mean, this you can realize this is pretty. This is tan theta minus tan alpha by tan. All right. So we got the x r by tan theta into this we can write as sine by cos. So sine theta by cos theta. This will become the formula which you know. Okay. And you can take the LCM. So this becomes r upon sine theta by cos theta into the other part will become cos theta cos alpha, and this becomes sine theta cos alpha minus cos theta sine alpha. Now this looks nice. So what we are getting is r sine theta minus alpha upon sine theta. Now this is x value, and
The
once
cost
you get the cos alpha, yeah. So this is cos alpha. Now once you get this answer, I think we know how to replace r value, right? And what is x? You're finding the intersection x, so you got this, the x actually, this x. So we know the formula for range, which is v naught square sine 2 theta by g into sine theta minus alpha upon sine theta into cos alpha, and this is exactly what we did. So v naught square by g, and we can add sine 2 theta as 2 sine theta into cos theta, which will cancel out the denominator of sine theta. What you left with is this into 2 sine theta minus alpha into cos theta. Now let's go back and check. Oh yeah, it's the same answer. It's the same answer. No, this part. So what we are getting is the x part. This v not cos theta into t is the answer. What we are getting. So you got the x value, the x coordinate, and then let's say if I call this range as r dash, maybe because I have taken r as a symbol. So what is r dash? So r dash cos alpha is x, and therefore the r dash is x by cos alpha. Exactly the same thing that we did. Now, what you can realize that there is never a unique way to solve question of Projectile. There is always a variety of ways in which you can solve it. Understood? And now I have to maximize the range. I have to change the range which is maximum. Like how we can set this equation to maximize. You can do it graphically. I mean, of course, you can. I mean, if you want to see the animation, I can go back to GeoGebra. I can show you. But one thing is clear that as theta will change, the range will change. The r dash will change for sure. Okay. So do you want to see the animation, or we can go directly by mathematical? It's okay. So let me show you. Yes. So now the next step is okay. Now remember this range is different. The r I have used for here. This r. This is r. I have taken OA as r. Okay, in the first derivation. I have taken r as OA. Okay, I have written already. No issue. But in the second case, what I am doing, I am taking r dash as my range. This is O. This is A. This is B.
So we can find that. So you have find that range only by the projection of that.
No, no, no. See, we have done by two methods. So now you can do by the third method. What is the third method? So we can solve the range by at least maybe 10 methods. Now, how many methods you can think of? It's up to you. Because at the end, it's just a mathematical construct. Like we know we can do various mathematical uh, processes here. Like you can do many things. I can show you a few of the mathematical things that I know. But if you know something more than that, you can do it. Let me show you something interesting. So this part is not there, of course. Or if you want, you can remove this part. So why these are important? Because we are trying to prove that okay, the motion is indeed parabolic, and what you're doing is you're intercepting the parabola at a point before it lands back on the ground. So you're intersecting here. So our journey stops here. Okay, so there are many ways to solve this question, like actually many ways. I mean, you cannot imagine. So I can show you the other way of thinking. So for range is nothing but why I'm writing this as C. Let's call it B. So C. Okay, that's B and this is B. Now how to find the range? So the other answer is range is nothing but the x dash minus x naught dash. That's and what we can write here formula ux dash t plus half ax dash t square. Can we use this formula? The x dash displacement is the range, isn't it? During one time of flight. So even this is the easy way of thinking. Like we can directly substitute and then answer. What is ux dash? Can you tell me?
V naught
V naught cos
cos theta minus alpha.
So V naught cos theta minus alpha into time of flight we know already plus half. What is ax dash?
G minus G sine
Minus G sine alpha.
But you can also understand this is really cumbersome because you need to substitute t two times, right? And that was the reason I was not. I mean, I was hesitant to use this method because it's really cumbersome. But it will indeed give you the answer. So if you process, I mean, you proceed, and if you do the calculation, you will get the same answer, exactly same answer. The only problem with this method is it's lengthy, and that is why I was trying to avoid this method to arrive at the alternative methods. But now I have got some new ideas which I would like to share with you all guys. My new idea is for any projectile, can we find the x and y coordinate? I'm not saying x dash y, I'm saying x and y. So let's say you reach x at time t. So what is the x? I mean, what is x this coordinate? What is x component? Let's name it something else, not xy, because this is the one particular point, not general point. So can we say this as uh, what we can say? What is the better way of saying this?
x1 y.
H is the y. That's good. And this is L. Okay, that's just name L comma H, just like that. Okay. Because this is one particular point of the trajectory. And finding L and H is not a big issue. What is L by the way? L is the horizontal displacement, isn't it?
V naught cos
Oh,
theta t. Cos
no,
alpha t. Sorry.
no, cot theta, not alpha. The V component along the horizontal is V, not cos theta.
Okay. So theta is the whole angle from V naught.
Yeah, it is theta is the whole number at the same time. Theta is always taken from the horizontal. That's now what is the h, the height? How to find height? So you have to write the vertical motion. What you can write vertical motion in time t? What you can write? It is v naught sine theta t minus half gt square. That's simple. Not a big deal, isn't it? So if I choose t as a time, then I can write L and H both in terms of t, isn't it? This has nothing to do with the inclined plane. This is just the projectile motion we are writing. Is this clear? Yes or no?
Yes.
Understood? No.
Yes, sir.
Okay. Now, once you write this expression, there is something very interesting which you know already. The relationship between H and L is known to us in advance. And from where that relation comes? The triangle OAB. In triangle OAB, what we can say about H and L? Are they
Tan alpha
related?
equals to H by L.
And that's why this is the new method to get the time of flight. Isn't it fascinating? Like we can do this way also. and then one t will cancel out. So we can cancel out one t. So we'll get v naught sine theta minus half gt upon v naught cos theta is tan alpha. Okay, so now you can add next is, so what you can add is half gt turns out to be v naught sine theta minus v naught cos theta into tan alpha, which is tan alpha by cos alpha. This will become v naught by cos alpha, and I can directly add sine theta cos alpha minus cos theta sin alpha, and we know the answer how to do this. So the turns out to be 2v naught by cos alpha into, and this is what? This is sine theta minus alpha. Now eventually the same answer. In how many ways you can think? I mean, this is interesting. This is going to be something very interesting. I'm trying to give you all the possible ways in which you can exploit the mathematics to arrive at the answer of your interest. And once you get the time of flight, the t, you can substitute in any value to get L. And once you get L, you know how to get the R. If you know the H, you know how to get the R. So finding the range is not an issue. What is the first step of solving the question of inclined plane is how to find the time of flight. And with time, you will realize that it is not confined with one method. So there are various methods in which you can find the range and the time of flight. So probably you have seen so many methods like to solve this question. Okay. So do you want to see more methods?
Yes.
So you guys are really greedy, yeah? So let's go to the next method. Maybe this will open your eyes. So now this method is pretty interesting, and we can solve just geometrically without using any concept of projectile. So what I do is, so you're throwing a projectile at some angle with horizontal, always I say theta v naught, and it's landing somewhere there. All right, no issue. And we know that this projectile is landing somewhere here, but the formula of the displacement triangle, if you remember, delta r equals to u vector into t plus half g vector into t square, because the only acceleration acting is g. So this is a resultant of these two vectors. So we treat each vector separately. So we know that if there's no gravity, this would have traveled this way forever, right? But actually, it is landing somewhere here. So what you need to realize that this is landing so this triangle is indeed V naught T. So what is this height? The vertical height is how much? Half G T square. That's it. And if I extend this line, because that is not the half G T square is only till the you hit the plane. Because after time T you are hitting the plane. So I can draw this diagram, isn't it? This is the triangle I can draw. And this is my R. And my job is done because I know every angle. So I know this angle is how much? 90 plus alpha. If you look at the biggest triangle, like O A B C. So when you see the triangle OAC, in triangle OAC, this angle is theta, this angle is how much? 91 theta. Can you see that? In the biggest triangle, OAC.
Yes. So how is that 90 plus alpha?
Pardon?
So how is that angle 90 plus alpha?
The exterior angle is equals to sum of the far two interior angles. Do you know this formula?
Yes, sir.
In the lower triangle, the 90 is here, alpha is here. So what is the exterior angle? The
Yes,
sum of the
understood.
And if you don't understand, you can find this angle and then subtract from the 180. Up to you. Okay. Anyway, now it is clear. The angle part is clear. Okay. So in triangle OAB, we can apply the sine law. That's over. Apply sine law, and we can write directly R by sine 90 minus theta is V naught T upon sine 90 plus alpha equals to half GT square upon, okay, this angle is how much?
Theta.
Sine theta minus alpha. So we are writing in that triangle. So the angle opposite to AB is how much? Theta minus alpha. And if you solve the last two terms, you get the time of flight. Yeah, your job is done. So half GT square upon sine theta minus alpha equals to V naught T upon cos alpha. Yes. On T I can just cancel. So I got the T equals to how much? 2 V naught sine theta minus alpha upon G cos. So that's really nice. You can do in one line. Yeah, that's great. And what else you can do? You can find the range
Range.
using the first. If you use the first, you can get the range quickly. So range is nothing but the V naught T by cos alpha into cos theta, and that's pretty easy. This is exactly what you did earlier, V naught cos theta T by cos alpha. So you can see that we have various methods to solve the question of inclined plane. It is not just one method. And the displacement triangle method is the most powerful method. So it's up to you to choose the method, and only practice can tell you which is the best way to do it. So
So
in the
that V
beginning,
naught T and half GT square, sir, how we got that V naught T and half GT square as a sides?
what is sine law? Do you know sine law? Do you remember sine law?
So
No.
no, I'm asking that V naught T, how we got that AO equals to V naught T, AB equals to half GT square, like that.
Okay. So look at this triangle. The first term is ut. So as time will grow, this will also grow. So if you have thrown in the direction of v naught this way, so in time t, how much will travel? Imagine there is nothing like gravity. Imagine this is not present. So if you throw this way, it will go this way only, right?
V naught T, yeah.
Now, in the same time, how much gravity will pull you down? In the same time, gravity will pull you down by half gt square. So you, after time of flight, you are actually here, na, at b. So if the first vector is taking you at a, so who must be bringing you down to b? It is half gt square. So it is the second term which brings you here, and that's why the resultant displacement is OB, that is R. So what we are using is the triangle law of vector addition, if you remember. This is the triangle law of vector addition, and we have done this in past also in vector. See, this is the first vector, this is the second vector, and this is the third vector. This is the triangle. Of course, this is difficult for you if you not getting this sense of vector notation. Then you have the other methods. So I have shown you all the possible ways to think. Okay. So think in all possible ways and get your answer. All right.
Yes, sir.
Okay. Okay. Let's do some interesting question by the concept of coordinate system. Okay. Imagine you throw a projectile. So in the beginning, you're throwing at an angle theta. So question is, after what time the final velocity vector will be? Let's say this is v0. So I'm looking for the time at which the velocity vector at that instant is perpendicular to the initial velocity vector. So let's say at this point the velocity vector finally is here, and this is exactly perpendicular to the first case. So if this is t equals to 0, when this event will happen? What is the t equals to t at which the velocity vector is perpendicular to the initial velocity vector? Okay. So when this will happen? Now this question can be solved in thousand ways. Like, of course, the vector wave method, but now my intention is to show you by the method of basic, you know, kinematics. So what we can do is we can choose this as the x dash axis, and our job is done. At this point, what is the velocity direction? This way, isn't it? So after time t, what is the velocity component along the x dash? So if I choose this as x dash axis, I mean my question is simple. What is vx dash at this instant?
0.
Zero.
Exactly. That is the idea. If you can get this idea, you can directly add the answer as vx dash equals to ux dash plus ax dash into t, and you can solve the question. That's it. Why? Because if you give me one idea, I can solve the question because I can explore the expression. And that is how we think in kinematics. Like, give me answer in one direction. At least tell me something about one direction. I will explore that direction actually. So now you are saying that there is no velocity in the x dash direction, and that is my key. So I will go ahead with that direction as my plane or inclination, and we'll solve the question. So what I can write here? 0 equals, what is ux dash? If you remember, what is ux dash? Can tell me. What is ux dash? What is the initial velocity in the x dash direction?
Sir, it is
V naught cos.
sir zero,
Repeat.
you know.
What is the u initial velocity in the direction of x dash?
V naught cos
Sir, we not
Just
cos
v naught, guys. Why cos it? You are throwing with v naught. So what is the initial velocity in the x dash direction here? Look at here.
V naught.
So I think you're not getting this one. The velocity in the x dash direction. What was the velocity in the beginning? V naught, and now that became 0 after some time. Okay. What is ax dash? What is the acceleration in this direction? So you can draw something like this. G is acting this way. So this angle is how much? So what is the component of G along the x dash?
Minus
sir
G
Minus
sin.
G
minus
cos
G cos 90 minus
Minus G
theta.
sin theta.
correct. So what we are getting is V naught minus G sin theta into T. So T is how much? See, I'm using the concept of plane, like inclined plane. And see, there's no need for the object to move in that direction. It's like we are playing with the component all the time. So you can write the kinematical equation in any direction as you wish. You're not confined to like one particular direction of writing. It's like which information is available to you. The moment you know your information, like I know that this information can be extracted if I choose this direction, just run in the direction. Just create a new set of coordinate system in that direction and just hit the equation. That is how we think in projectile. This ability is the enormous. Like if you can see the component and if you can play with it, you become the champion of kinematics. So kinematics is all about understanding the component. All about. I'm saying it is actually component. So the more you understand about component, the better you will be at uh, kinematics, especially the projectile part. And it is not easy. It is definitely not easy. So this requires a lot of thinking, practice, and you have to devote your time only for kinematics for some time. So like solve as many problems as possible, not like 30, 40. I'm saying at least solve 200 to 300 to 400 problems. You may ask me one question like, sir, how many you solve as a student? I can tell you the answer. Do you want to ask?
Yes.
Yes, so
Okay, so for this particular chapter I solved around 400 plus questions as a student, highest in my class and highest in the history. So no one has solved so many questions. Okay. The idea is I loved this concept of projectile, and I was using all these ideas on my own. So I naturally got these ideas. Okay, how to do this. So I was solving one question in four ways, three ways, two ways. Like every method which I ever thought of, I tried, and that made me rich. So I'm really rich in terms of things. So this kinematics chapter is something which develops the thinking ability of every student, and therefore you should not treat this as one chapter. This is like the puzzle part. Like you're training your brain to think in variety of ways. And once this idea is in your brain, you realize that you can actually play with the rest of the physics. It's actually so easy. So just develop your idea once, and you can reap the benefits throughout your life. So kinematics is the chapter to go. Just hammer the chapter as much as possible. Like solve every question which comes your way. Every question without getting bogged down by the difficulty of it. Spend every second you have in your life. Sleep less number of hours, but make sure that you are learning thoroughly. So don't make this chapter as a syllabus. Like okay, I have to finish the syllabus because it's part of my exam and all. No, this is the part of your life. So kinematics will define your thinking process. Once you refine your thinking, you're good to go with it. Anyway, this is one way of thinking, and what I was trying to explain is how we can actually exploit the concept of a component to solve any question. Okay. Of course, you can solve this question by the vector method. We know the v dot u equals to 0 because so method 2, and we can write as u plus gt dot u equals to 0. So u dot u plus g dot u into t equals to 0. What is u dot u? It's u square. Basically, it's a v naught. What is g dot u? So what is the angle between GU? GU cos the angle between G and U is how much? You can see this is G, this is U. This angle is 90 plus theta. So V naught is square plus G V naught minus sin theta. So this is so cos 90 by theta is minus sin theta. Again, you get the answer V naught by G sin. In what other ways you can solve? Method 3, drawing the velocity triangle, which is easiest way to solve. So we know that if I throw a projectile at angle theta, So we know v vector equals to u vector plus gt vector. So I have to create gt vector in such a way the final velocity becomes the right angle to the initial. So this angle must be right angle because this is my final velocity, and the vertical length you can see is the gt. So this angle is 90 minus theta, and in fact you can see this angle is theta, and you can see in this triangle gt sine theta itself is v naught because gt is acting as a hypotenuse. So we got the answer. Oh, this is quite interesting. And maybe I can show you the fourth method using the displacement triangle. So how we can solve using displacement triangle? So you're throwing, so you're throwing in a way that your maybe this should not work. All right. So in time t, how much you travel? So if you're throwing this way,
V not T.
yeah, it's v naught. And in the same time, you have traveled down by half gt square. But this will give you velocity and this will give you displacement. So displacement triangle, can we use this? No. Mm, no. No. So we can use the only velocity triangle. This is difficult. Yeah, using this triangle you can find other things, but you can see that there are various ways to tackle one problem. Whenever it comes to the perpendicularity, we know how to go about it. So we have solved like this, like this, like this. There must be some more method. Yeah, we can solve by some more method of. So we can also write things in component, like we can write v vector equals to vxi plus vyj. You can just call it method 5. So, and writing in I and j component is, so what is vx? It's v not cos theta I cap. What is vy? V not sin theta minus gt j cap, right? And what is u vector? U was v not cos theta I cap plus v not sin theta j cap. So I think this is what we can write. And what is being said? What I am writing? What is, yeah, fine. So u vector is this, and this is a v vector. And now we can write v dot u is equal to 0. So I will go with I. So we can write as v not cos theta whole square. And j will go with j. So v not sin theta into v not sin theta minus gt equals to 0. Because I dot I and j dot j. So we are getting v not square cos square theta, v not square sin square theta minus v not sin theta into g. Now the first two term becomes v not square and equals to v not sin theta into g. Again you get the answer.
Sir,
Yes.
sir, why you did that V not sin theta minus GT? Okay.
What is vy? How you write vy? Uy plus ayt. What is uy? What is ay? We have done this, guys. Come on. So we are writing the instantaneous velocity in the y direction, right?
Yes, sir.
And instantaneous velocity in the x direction is constant because we know there is no acceleration in the x, isn't it?
Yes, sir.
No. So definitely there may be some more methods to solve, but I will stop here. Okay. So these are the ways of thinking in projectile. So let's do something interesting. Okay, we have done the one part, which is like let's come back to the up the plane projectile. So I am still not done with the inclined plane. There's something still left, which we need to explore. So when you throw the projectile at some angle, and if it goes like this, so what we discussed that as theta will change, then the range will change. Like the range means here the range up the plane. So for what value of theta I can maximize the range? I have to maximize the range for R max. So first we'll add the
40.
formula for which is V naught square. No, that will not work. V naught square by G cos square alpha into 2V, I mean 2 sine. So this is the formula for range. You can just check. So you can just check this one.
Yes.
So now to maximize this, there are two ways because it's a function of theta. So there are two ways. You can take this function and differentiate with theta, and you get the answer. So you're gonna dr by d theta. This is the calculus way that will not appreciate. So don't do this. Although nothing wrong in this, you can go about this also. So if you differentiate, what you get? Just everything is constant. 2 v naught square g cos square alpha. So we have to only uh, differentiate with theta. So we can use the product rule. So d by d theta of psi. You can add this sine outside. Differentiate cos will give you minus sin theta. Plus take cos theta outside and sine will give you just cos theta. So what you can see that sine theta minus alpha into sine theta is same as cos theta minus alpha into cos theta, which is like if I bring sine equals to cos theta by sine theta. The first term becomes tan theta minus alpha, but the second term is cot theta, right? So which you can also write as tan 90% because that's where we can compare and we can see something. What we can see? The theta minus alpha is same as 90 minus theta. It's always solved because both are tans, we can compare the angles. So what you are getting is 2 theta is 90 plus alpha, so theta is how much? 45 degree plus alpha by 2. So if you throw at this angle, which we write as pi by 4 plus alpha by 2, it will have the maximum range. Okay. So the best way to solve this question is you can replace theta by pi by 4 plus alpha by 2. You can use this formula because theta is the variable, right? Okay, so this is one way of thinking or doing the question. You can find the angle like this. But to find the R max, we need to now substitute the naught. Okay, so we can take 2 outside. Then yeah, so we can do one thing. Like we can use something interesting called 2 sin A sin B, 2 sin A cos B. It's a sin A plus B. It's a sine A plus B plus sine A minus B. And this turns out to be really nice expression. Oh, let me not R. This is R actually. R max we have to find actually. So what we can write R as sine 2 theta minus sine alpha, because theta will cancel out and sine of minus alpha will be minus alpha. Now what we know that from the earlier derivation, or in fact we can directly see from here, or you can see from here, that up to you. So this we can write as 2 theta minus alpha is, from here we can also write like this. So basically 2 theta minus alpha is 90 degree. So the first term, or you can think this way. Let's say range is this much. I mean, I'm not using the formula which I derived. Imagine I have this answer of range. The only variable that we can see is the first term in the bracket. Everything else is constant. Do you realize?
Yes.
Everything else is constant. So now tell me, to maximize R, we must maximize this. What is the maximum value of sine?
One.
1. So the R max is very simple. V naught square by G cos square alpha 1 minus sin alpha. That's simple. That is R max, nothing else. But we can also simplify this as V naught square, and we can add 1 minus sin alpha. That's nice. But we can also add cos square as 1 minus sin square alpha. And then this becomes G1 plus sin alpha, because 1 minus sin square we can add as 1 minus sin alpha into 1 plus 1 plus sin alpha. That will cancel out. And now we have the formula, the R max. V naught square by G 1 plus angle of sine of angle phi. And when this happens, when this theta is, all derivations I have put into place, and either you can differentiate, and no need to differentiate, because as I said, sine 2 theta minus 1, sine 2 theta minus alpha is 1. So this will automatically give you 2 theta minus alpha 90, and you can get answer from here. So no need to go for differentiation, and get, you can do it by common sense. Now this is the R max. This is what I was looking for, and I got it. Okay. So now one more thing I would like to calculate here.
Sir, I want to note the last page, sir. Little one. Noted, sir.
Okay. So now imagine now if y dash, if you remember that y dash first increases, becomes maximum, then again becomes 0, right? So my question is, what is the maximum y dash? That is, what is the h max from the plane? So we know that at h max from the plane, the velocity will be parallel to the x dash, right? So v will be parallel to the x dash.
0.
Yeah.
So
So
can
what is
we
z?
try this?
Yeah. So find h max. Do this.
Sir, is it V naught square sine square theta minus alpha by 2g?
Once again, V naught square
Sine square theta minus alpha divided by 2g.
by 2
G.
2g cos alpha, because the g in the y dash is not g, right? Y g acts in the y direction
Yes.
minus y. So you have to take
Yes.
the new g, the new acceleration. Okay. So yeah, so you got the idea correct, but just one small mistake. If you correct, you will get the right answer. So idea was to make vy dash 0, isn't it?
Yes.
And to find the maximum, we can add vy dash square equals to u y dash square plus 2 ay dash y dash minus y naught dash, like, okay, fine. So this is 0. This is v naught sine theta minus alpha. Why I'm using this color? And ay dash is minus g cos alpha. This is what you need to remember. This is h max. So the h max square turns out to be v naught square by 2g cos alpha. Okay.
So sine square.
Yes. So this is your maximum height. Okay. So yeah, that's interesting. Can you find the time taken by the projectile to reach here? What is the time here?
Sir, it will be
It will be.
uh,
Now, can we say the time of ascent is same as time of descent? Can we say the this time to go from
yeah,
O
sir.
to some?
Same.
No, we cannot say. We we never say this. This is always wrong. Now, this time T1, this time T2 are not same, because there is an acceleration in the x dash direction which will decelerate you. So every further journey will have slower velocity. So T1 and T2 cannot be same. Or you can think of common sense. I mean, common sense. What is common sense? This is the actual path, right? So now can you say that this journey will take same time as this journey? It's like random arc of the parabola, right? So how we can say that this time will be same as this time? There is no meaning of it. This is not even symmetrical. Is it symmetrical? No. This is confusing. This diagram is confusing. If you draw a parabola, if you draw, if it is symmetrical, then we can say this time is same this time. But how can you say this is symmetrical? Now suddenly you make this symmetrical. This is wrong. Is this symmetrical?
No, sir.
See, the diagram is confusing. It is always confusing, and we do it to make you confuse always. If you draw a proper parabola, I mean, okay, what is this? Bad diagram. Let me try a nice diagram. Maybe this. No, let me hide the other part. Okay. And now suddenly you draw a one straight line, and one fine day you draw a line, and then you divide the line. I mean, you say something like this. I mean, maybe like this. Now, in fact, even you can see that this is not symmetrical, right? So, is it a good idea to say this T1 and this T1 will be same, like from here to here and from here to here? You know this part. Now, can we say that T1, T2 are the same? Now,
No,
although
sir.
parallel, the answer is no, we can't say. Okay. Anyway. So the question is, what is the T? Now that's why I'm asking, what is T1?
Sir, V naught sine theta minus alpha into GT.
Yeah. So the T1 is time of essence. So we have to use the same formula. Vy dash is uy dash plus ay dash into t, and this is zero again. So this is v naught sine theta minus alpha, and ay dash is how much? Okay. So minus g cos alpha t1. So time of ascent we got is v naught sine theta minus alpha upon g cos alpha. So time of descent will be how much? The total time of flight minus t. And now you can see that this is a very weird answer. Like this, we answer we know 2v naught sine. Yeah. Are we getting the same answer? Yes. So the total time of flight is this much. Yeah, this is coming same time. Yeah, yes, yes. The time will be same. Why I said it's not same? Yeah, it will be same actually. I thought it's not so much same. G cos alpha minus v naught sine. Yeah, it will be same. I mean, my bad. I just thought something else. So the time of ascent is same as time of descent, although there is no symmetricity of shape. Yeah, so what you can say that there is no symmetricity of shape, but the time of ascent equals to time of descent. That's actually same. So T1 equals to T2. But is it, I mean, symmetrical? The answer is no. It is not symmetrical graphically. So for asymmetric graph, we have same time. So time taken is of course because we are solving in 2D. So the condition for 0 to maximum, maximum to 0, back to 0 is same. So the answer must be same. Yeah, that's correct. Because the acceleration in y dash is constant, which is g cos alpha all the time. So this must be same. Yeah, that's my mistake. So we have seen so many questions from solving this question. I mean, and you can use some more method also. Okay. So now we'll see the other part. Projectile down the plane. Now I will not discuss much because the discussion I have done. Now what I'll do is I'll just solve the question quickly. So imagine we have an inclined plane. In fact, you should go ahead and solve this question. And again, the rule of the game is same. We always throw with respect to horizontal. So we make sure that we are throwing this. And the angle we take from where? Also horizontal. So theta will be from horizontal. What is the angle from the plane? Theta plus alpha. So now my question is same. Can you find the time of flight, range, and so on? Of course you can find. The only difference is you have to choose two axes. One like this, vertical and horizontal, which you do always. And other will choose as down the plane. So that's convenient. If you choose down the plane, it's convenient for you. And like this. So this selection of coordinate is very useful. So this x and y will always be there. Yeah, that's always there. And now you can do the same thing. So can you solve the question now to tell me the time of flight and range? Find T and R. Are you solving, guys?
Yes, sir.
Yes.
Okay.
So y naught will be 0.
Pardon?
Y naught will be 0.
Why not? In which direction you're saying? Yeah, why not is of course zero because I've taken the origin there only, isn't it? So
Yes.
my y naught is zero, my y dash not is zero. Okay, but after some time, when you land on the plane back to the plane, is y zero again?
No, sir. So y naught will not be, sorry, y will not be 0. So it will
And
be, it is below the axis, like
yeah.
x-axis.
So what about the y dash?
So y dash will be 0 for each, for landing
Landing.
and ascending.
Yeah, correct. So the one key idea you got is y dash, and from there you have to derive the formula for time of flight. So use that formula to get time of flight, and once you are having this key information of time, you can play with the other coordinate, like you know how to play with the question. So go ahead and do the magic.
Sir, the x dash we have, which we have taken, sir, is it
Mhm.
positive?
Yeah.
Okay, sir.
So for x, the left of x is positive, and the down of x dash is positive.
Sir,
Hmm.
sir, I got time of flight as t equals to 2 v naught sine theta plus alpha divided by
Hmm.
g cos alpha.
That's correct. Absolutely correct. So once you know the time fund, you can find the range because you know how to use the trigo.
Yes, sir.
Good.
Sir, done, sir.
What is the so you got range?
Sir, I mean,
Okay, do this.
sir, I mean time of flight.
So what is your time of flight?
Sir, it's 2 v naught sine alpha plus theta by t. Sorry, t cos alpha.
Yeah, that's right. Find range, both of you. All of you.
Sir, range will be same no if instead where the theta minus alpha was the theta plus alpha will be there.
Yes, that's correct. So range will be same answer. V naught square by g cos square alpha and 2 sine. Yeah. And again, you can find the R max. For R max, you would first need to write this into a better way of writing of sine A plus B and then plus sine A minus B. This time it will be alpha. This will be plus. And then for R max, we have to maximize this one. So for R max, sine 2 theta plus alpha must be equals to 1. So the theta will be pi by 4 minus alpha by 2, just minus will come back. And the R max becomes V naught square by G cos square alpha 1 plus sin alpha. And therefore, if you simplify further, you will get 1 minus sin alpha. So this is the final answer of R max. So down the plane, if you throw the same fashion, you will get bigger distance, but you will travel farther compared to the previous case. So now this is the up the plane, down the plane, and now comes something called there's some special cases. Now these are cases in which I will provide you some extra information to solve the same question. So you stick to the old method because that you know, and any additional information which comes your way will give you the same answer. Not same is like will give the answer of the same parameter in a different way. Like it will look like different, but numerically they will be same. So the rule will be find the answer of the, let's say, time of flight by the old method, and then find the answer with the new information. So the moment I give you new information, try to exploit it and then solve it again. So let's do this question. So the question is condition for hitting the plane perpendicularly. So now let's say we have the situation like, and just I want to make sure that anyone throwing the projectile from the bottom is hitting this plane at right angle. So the projectile you're throwing in such a way that after it is hitting it right angle. Now after this, of course, the motion will stop. So at the moment of the impact, the velocity vector is just right angle to the plane. Now this is what we have to exploit as information. So when you hit at right angle, that becomes a really nice way of giving you alternative answer. So at the point of impact, what is the velocity in the x dash direction? Now that is obvious information. So what is vx dash here? 0. Okay, so I have just exploited the information. So the way you were solving earlier, that will continue. So now, in how many ways you can find the time of flight? In how many ways you can find the time of flight? You know y dash is 0, so that's one information. And now we have one additional information. In fact, vx dash is also 0. So I can find the time of flight now in two ways. Earlier I was having only one
V
way.
is equal to U plus A.
Yeah, so you can solve by the delta y dash is 0 and vx dash is 0. And from both the condition, we can actually find the same answer, time of flight. And the rule is equated because they are same thing. So if both are giving you time of flight, so they must be numerically equal. And the moment you equate to get the condition is very easy to find. Now, if you are carefully, I mean, if you observe something here, every time when I give you extra information, that act as a, you know what, like, of course, the moment I say it is hitting this way or hitting that way, like these are some sort of, hint or clue that now use this information as at your advantage and then get your answer. And this is exactly what we do. Like every time I come across a new situation, okay, so I'm really happy. I know that okay, that I can exploit in one way or the other. So can you exploit this information and tell me the condition? Like some condition will come. Condition means a relationship. So can you write the time of flight using the two conditions first of all and tell me the answers? Do it.
Sir, it would be 2 V naught cos theta
Mhm.
minus alpha upon G sine theta.
G
Sine theta.
theta? No. See, one answer we already know using the delta y.
Alpha, sorry.
This answer we know already. This is the time of flight using the first expression, right? But can you use
Yes.
the second expression to get me the another way of writing the same answer? So Vx dash equals to Ux dash plus Ax dash into T. Like we know this already. What is Ux dash? V not cos Ax dash is G sine alpha. And if you solve, in fact, we have solved this before. Now you can see every information gives you the a new answer, which looks new, but of course they must be same because that is what they're representing, the same time of flight. So from 1 and 2, what we can write? In fact, I should write. So from 1 and 2,
Sir,
yes.
sir, can this happen only when the V naught's direction is with the direction of projection? Like for some time it
Pardon?
is with like sir, if like V naught is in the direction of the ball, or suppose we are throwing a ball in the theta, then then the V naught is when the ball is going in direction of V naught for some time,
No, no, no,
and
no,
then
no. See, that's the wrong. You're not getting the point. At any instant, let's say I always try to resolve the velocity in two directions. So let's say at this instant, you will have some value of Vx and some value of Vy, or you can say Vy dash, something like this. Every time we can always express the Vx dash and then this is and then. The idea is like this is reducing now. And at coming to this point, this becomes exactly zero. Okay, I have drawn not properly. The idea is this is what we are doing. We are instead of resolving along x and y, we are trying to resolving along x dash and y dash. And the moment you reach here, the x dash component will reduce to zero. So it does not mean it's moving in this direction. No, this is not moving this way. This is moving, of course, along the way which we have shown. The behavior of components. See, every vector we can resolve into how many components? Infinite components. And if I say you that can you pick two mutually perpendicular component for the given vector as per the requirement. So here the requirement has changed. So let me in fact, do it in accurate. So what I'm saying is, let's say you draw a line parallel to this line. In the beginning, this is the velocity. Maybe it will reduce a bit. So I'm drawing every velocity. So here the y dash is this way and x dash is this way. After some point, let's say if you are here, the x dash is only present and y dash is 0. Then after that, the x dash is becoming smaller and y dash is growing in the downward direction. And then the moment you reach here, the x dash becomes 0 actually, and there is only y dash that which I have drawn. So what we are doing is we are trying to resolve the velocity into two desirable components, x dash and y dash, for the entire journey. And then what we are realizing that the moment you reach at the point of impact, the x dash component is vanishing suddenly. It's not there because you are hitting it perpendicularly. So that is like your information. Does it mean it's moving along the V naught? No, of course it's not moving along V naught. We are dealing with the component vector all the time. Okay. So every projectile which you throw, you can always solve the question in any random direction. That is what this is what I explained at the beginning of the projectile motion. How you can choose the direction. And direction does not mean it's moving in that direction. It means if you resolve the component at every instant in that direction, then that component will change continuously. That was the idea. Understood what I'm saying? If you resolve the velocity at any instant in x dash and y dash, then those components will vary with time. Okay. So don't say that it's moving along v naught. No, it's not moving along v naught. The v naught is the initial velocity vector. The initial means only initial. So afterwards, it's changing continuously. Understood? Is this clear? Whose dot was this? Hello, hello, hello. My voice is not coming.
So what, sir?
Hello, hello, hello. Am I audible?
Yes,
So do you understand what I'm saying?
yes,
So V naught is not the direction of motion. V naught is just the initial velocity. What is happening? V naught is just the initial velocity vector. It is not the direction of motion. Okay.
yes,
And what we do is we always deal with component in one particular direction. So if you try to look at the component along x dash at every instant, you will see that the value is changing. And at the time of impact, that component is vanishing. It's becoming zero. That is that. So once I make the Vx dash equals to zero, I get again the time of flight because this has happened at that instant. So the question is who is reducing the Vx dash? It is the G sin alpha because that is always acting that way. So G is acting downward, vertically downward, but G sin alpha is always opposite to the x dash axis. So now from 1 into what we can write? We are done with this. So from 1 into what we can write? 2v naught, 2v naught sine v naught cos let us see this we cancel out. So it has nothing to do with the what velocity. So once you have the angle fixed, you will get to cot alpha. So this is happening only at one particular angle. There are two ways of writing it. You can say this theta minus alpha is pi by 2 minus alpha, but this is not
sir.
possible.
It's too.
Yeah. So the other way of doing is we can write as tan theta minus tan alpha upon 1 plus tan theta into tan alpha equals to cot alpha. And then what we can add from here? Tan theta minus tan alpha you can multiply cot alpha plus tan 2 I missed somewhere. Yes. I missed the 2. Oh, no, it's fine. So what we are getting is that tan theta is how much? 2 tan alpha plus cot alpha. Yeah, that's why what I was doing was wrong actually. Because 2 we cannot eliminate, right? So this is the answer. It means if you throw at this angle, like if you know the plane angle, if you throw at this angle, it will always hit at the right angle, no matter what is the velocity. So you may be thinking, sir, what happens if I change the velocity? So it will hit either like this. If you throw faster, it will hit like this, even faster. So what will happen is the speed will only change the point of impact. But in each case, so as long as this theta is fulfilling the condition that we have derived, it is going to always hit at this angle. Now see how interesting this is. So let's say we have a staircase, and if you want to uh, water the plant, so we have plantation here, we have here, and then I want to plant every plant without. So if I change the velocity, I can water every plant distinctly without affecting other part. So that's very interesting. Or we can create some sort of a beautiful fountain pattern. Okay. So these concepts are actually used. Of course, if you in Dubai we have something called fountain show. In India also we have somewhere fountain show in which they use the light and fountain to create the effects. And all the fountain which is designed, they follow the concept of projectile only, because water will coming out of the tube at certain speed will follow the path of projectile, nothing more. So that is always there. I mean, these concepts are always in actually used, and they exploit this beautiful mathematical nature because they're not doing it manually. They create the fountain pattern using some software and embedded system. So it's like something really interesting. They spend crores in creating those fountains. It's not a cheap fountain. Anyway, so even if you want to, like water your garden, you use the concept of, okay, not you don't use. I mean, of course, we have ready-made faucet or maybe some the water outlets, which always works on this principle. Okay. So this is one special case, and this is the one special derivation, and we can do something more like this. Now, this question is pretty easy, and common sense will solve this question. I want to hit the plane horizontally. What I should do? How I should throw? So I want to hit the plane horizontally. What should I do? It's easy. Throwing horizontally means this must be the maximum height of the actual projectile, isn't it?
Yes.
So there is no physics here. It's very simple. So we know this is H max because that then only this is possible, right?
Yes.
So or better I can draw this way. I mean, this is so the other way of thinking is if we have a projectile and I want to hit the plane horizontally, which means the plane must be passing through the maximum height, right? And if this is so, then only this is possible. So the rest part of the graph is not required. So without even thinking much, we can solve quickly. They'll ask you find the theta when this will happen. So this is H max for the normal case, and this must be range by 2. This is alpha, so you can directly add answer. Tan alpha equals to how much? H max by half of the range.
R by
And we know the formula. What is H max? V naught square sin square theta by 2g. Notice our formula. V naught square, sorry, what I'm doing, sin square theta.
Sine 2 theta by g.
And 2 theta by g by 2. That's it. So what we're getting is sin square theta by sin 2 theta, which is 2 sin theta into cos theta. So we are getting tan theta by 2. So the tan theta is how much? 2 tan alpha. That's it. So theta is tan inverse. So hitting the plane, horizontally. So with this question, we can actually end the projectile motion, but there are very large variety of questions which is available. Okay. So now what I'll do is those questions I'll give you as a tutorial, and then you practice. You come up with your own solution with these so many ideas you have learned, and then we can solve those questions as a doubt. Because if I solve everything here, then what you will learn? That's the problem. So I'm not solving every question, but definitely I'll give you those questions so that you can practice, you can understand, you can get more insight. So this is how we are ending the projectile motion, and what we will be starting tomorrow will be the relative motion. So I will be sharing you the sheet of projectile motion. You can start solving that sheet. It's really nice and having really large collection. So in fact, I will share before I end the lecture.
Sir,
Yes,
sir, please will you send this PDF on
yes, of
after the
course.
lecture?
I'll send right away because else I will forget actually. Normally it happens. If I'm not sending now, then I will send after a long time. Okay, anyway. So okay, I got the sheet. Let me share this first. So you can start solving from this sheet directly, okay, which is already shared on the group, and I'm sending you this PDF. Okay. Okay. So any doubt? I'm ending this lecture.
No, sir, no. Sir,
Okay.
sir, sir, एक minute. Small
Yeah.
doubt.
Yes.
Sir, why after means there are many formulas for projectile motion in horizontal and both oblique also.
See, there is no formula. Actually, all are derivation which you can do from basic. So the idea is when you're solving question of projectile motion, do not remember any formula. Again, go to scratch and derive. Like my idea is always go to scratch. That's it. Always. Never try to remember any formula. If you're remembering formula, you are doing wrong to yourself. Go back to very scratch, read, derive, then solve. And make sure that you derive very fast after some time. So the speed with which we should derive should be very high instead of remembering the formula. That will never work. No. Yes. Tell me.
Yes, sir, that was only the question, sir.
So I hope I have answered. Okay.
Thank
All
you,
right.
sir.
Thank you.
Bye, sir.
Bye.